Good morning, ladies and gentlemen. My name is Prihandoko. I'm from Gunadarma University in Jakarta, Indonesia. I'm very happy to be here today to share about the deep learning and some implementation of deep learning. Thank you very much for the committee who have invited me to join this prestigious event, International Conference on Computational Methods and Science and Technology from Chandigarh Group of College. I hope that this conference will be fruitful for all of you, the participants, and also for the researcher and for the academician. Let me share my presentation slides for today. So the topic of my talk is about the deep learning approach for object recognition by using convolutional neural network. As we know that deep learning has already been attracted many attention from researchers and academicians and also industries to be used to solve the problems that they have. So the outline of my presentation today will be the motivations of this topic, the concept of deep learning, the convolutional neural network, and conclusions. As the motivations, we see today that there are a lot of data that are around us now. Say, I give you some social media that are everybody every day are using this kind of social media. Like for example, in YouTube, in a minute every day, in every minute, there are 72 hours of new video uploaded by the people to YouTube. 72 hours a minute. Yeah, the size of video, you can imagine if one video takes 1 gigabyte for 1 hour, then for 72 hours should be 72 gigabytes storage that should be provided to accommodate this kind of videos. A very big, very huge amount of storage that are needed to accommodate this. And also in Facebook, more than 2.4 million pieces of content are shared by people, by the users, through Facebook. Yeah, in a minute. We can imagine how big is it in an hour, in a day, in a month, in a year. In WhatsApp, there are more than 347,000 photos are transmitted every minute. In Instagram, more than 200,000 photos are uploaded through Instagram. So many other media that are used by people now are creating photos, videos, tags around us every day. So many people now are also using smartphones that have cameras. Maybe 5 or 7 years ago, we have only one camera in a smartphone, but now you can find 2 cameras in smartphones, even 4 cameras in a smartphone. Yeah, so everybody can be a photographer to take photos and then save it in the smartphones, and then someday in the future they can look at the historical life through the photos. So since there are no signs of this will be slowing down, digital photo numbers to continue to grow very fast. Yeah, according to the data from 2017, there are 1.2 trillion photos are taken by people. 1.2 trillion, and there will be 4.7 trillion photos are stored. Yeah, a lot of photos. Then, what are the challenges that we have regarding this photo? Yeah, how can we find a particular photo by using text? Sometimes we need to find some occasion in the previous year on the back several years ago. Then it is difficult for us to find a photo regarding some event or some occasion that we have already been there before. Yeah. And secondly, how can we describe what is happening in a photo automatically? Sometimes we need the system to identify what are the objects in a photo, and then what are the interaction between the objects in the photo. Yeah. And of course, the third one is what are the objects in the photo? How can you identify the objects in the photo? Yeah. How can we classify similar photos? Yeah. I found that in some applications in our smartphones, they can identify duplicate photos. It's very good. But then is it accurate? How accurate is it? That's the challenging for the researcher. And many other challenges that we have that we can find some problems or some solution for all the photo. Now, for example, we have some photos here. If you look at the photo, the first photo in the left side, upper left side, you find a cup of coffee, a bread, and it is a kind of breakfast. Yeah, we as human can identify these photos easily. This is breakfast. This is in the night. River with the bridge. There's a dog with snow behind the dogs. That's a railway station, train station, transportation, and that's a river. But if we want the system to identify the condition or the situation in a photo, it is not easy. Yeah, because the system should identify what are the objects first, and then what is the background of the situation, and what is the interaction between the objects in the photo. Yeah, that's our challenge now, because as long as I know, like in China, they have already implemented, or they want to implement it. They plan to implement 1 million CCTV camera throughout the country. So you can imagine if those CCTV camera are to be analyzed, are to be used to identify some persons that are interested to recognize, then they will need this kind of system. Yeah. Another example of this problem, if we have these photos or this picture, we can find a crowd. We can find somebody is holding something. We can find a color which is purple. We can find a woman. We can find a camera. We can find a cat. So the first algorithm will need to identify what are the objects in the picture. But then we don't just need the objects to be identified in the picture, but we need to have a sentence to describe what is happening in a picture, right? So there are three processes that can be followed. First one is word detection, so detection of the objects, and then how to represent the objects in a word. Yeah, woman, crowd, cat, camera, holding, purple. And then sentence generation from the words that are found from the picture. we need to create a sentence, to generate a sentence, to describe what is happening in the picture. So for example, this system will come up with a purple camera with a woman, a man holding a camera in a crowd, a man holding a cat. There are some possible sentences that can be created to describe what is happening in this picture. Then we need to make a ranking throughout these sentences to find the most suitable or the most accurate sentence to describe this picture. Say, for example, in this case, a woman holding a camera in a crowd. Say, this is the challenge that we have, and we want to solve this kind of problems because the situation very different between one pictures to other pictures. Okay, let's see another example. There's a woman in the kitchen. As a human, we will say that a woman working on a counter near kitchen sink preparing a meal. But a machine could generate different sentence, which is a woman in the kitchen preparing food. More or less it's the same. Yeah, but then there might be a different sentence will be generated by the system. It will depending upon the algorithm that's used to generate the sentence, to identify the objects in the picture, and so on. Yeah. Another example, we have a man holding a tennis racket and on a tennis court. We as human can say that the man is on the tennis court playing a game, playing tennis. But the machine, maybe they don't have any knowledge about the playing game because they only find objects in the picture. Yeah, the objects are a man, a racket, tennis court, right? So this is the problems that we have if we want to generate a sentence to make a description about a picture. Yeah, it's not an easy problem to solve. This is more complicated. Yeah, these pictures are more complicated. Two young girls are playing with Lego toy, the left hand side, the left part. Boy is doing backflip on wakeboard. Yeah. Construction worker in orange safety vest is working on road. How can we generate this kind of sentences to describe the situation in the picture? Man in black shirt is playing guitar. Yeah. So the first step should be we recognize the objects first, and then after that we identify the interaction between objects. That's why the deep learning concept is coming, and then we will use deep learning to identify the objects and then to create the interaction between objects. So basically, deep learning is a subset of machine learning. We have already known machine learning, and machine learning is also a subset of artificial intelligence. Yeah, which is a technique that enables computer to mimic human intelligence. Yeah, and machine learning is a subset of AI that includes techniques that enable a machine to improve a task with experience. So we make the machine to learn, yeah, from the data that are fed to the machine. And after some learning process, the machine can identify the objects. And deep learning is a subset of machine learning based on neural networks that permit a machine to train itself to perform a task. So the application of deep learning is everywhere now. In internet and cloud, deep learning is used to the classification of image, to recognize speech, to translate language. I'm very happy if sometimes we have very fast and quick response of translation between language. so that we can speak to other person in different language fluently, smoothly. Say, for example, if I go to India and then I talk to Indian people, I use my Indonesian language and the Indian people use their own language, but then we can still chatting and make some conversation without any problem. Yeah, if we can use them, we can have the machine like that. It's very nice. Language processing, yeah, natural language processing (NLP) is one of the problem that can be solved by artificial intelligence or maybe deep learning in the future. Sentiment analysis, to analyze the sentiment from the comments of the users from the internet or something like that. Recommendation, medicine and biology, cancer cell detection, diabetic grading, and etc. In media, entertainment, video captioning, video search, real-time translation, etc. Okay, and also in the autonomous machines to make a car without driver, right? Okay, these are the deep learning areas that can be used by us, by researchers, to do some research on that area. Basically, the concept of deep learning is try to move between the perception of people, how a human thinking, to the concept. So in deep learning, we try to create algorithms that can understand scenes, that can understand the picture and describe them in natural language. Yeah, that's the problem that previous slides that I have explained in the previous slides. So how do we understand the scenes, and how do we describe the scenes in our natural language? And secondly, we have to create an algorithm which can infer semantic concepts to allow machines to interact with humans. That's the major problem of identifying objects. Yeah, because machine does not know the semantic or the meaning. They only know the symbols, syntax of the picture or of the text. But the machine does not know the meaning, does not know the semantics of the objects or of the text that are read by the machine. So that's the most challenging problems that we face, how to create an algorithms to get the semantic knowledge of the pictures or of the text. So basically, this algorithm requires creating a series of abstractions from image in pixel intensities, and then we identify the objects in image, then interaction between objects, and scene description. So the steps is like that: image from the image, and then we identify the objects, and then from the objects we identify the interaction between objects, and then generate a sentence. So deep learning in this context aims to automatically learn these abstractions with little supervision. What is the difference between computer and human? Human, if we look at this motorbike or the motorcycle, we can say immediately this is a motorcycle, right? But computer see this motorcycle as a collection of numbers, right? If you see at this picture, a small part of this motorcycle consists of many numbers, right? Consists of many numbers. Can you imagine how many numbers are in the whole picture of this motorcycle? Yeah, and it is very hard to identify the objects. That's why artificial intelligence, actually artificial intelligence has already come to the world since 20 years ago, but then because the power of our machine or computers cannot handle the algorithm of artificial intelligence at that time. The artificial intelligence did not pay much attention from the researcher, but now it's coming again, and then because the power of the computer has already quite high, and then the storage is also very big, then we can handle this kind of problems easily. So basically, deep learning process is like this. From pixel, we identify the feature of the objects through edges, and then the object parts, and then the model of the objects, right? So the difference between machine learning and deep learning is basically in machine learning, the feature extraction should be done manually, but in deep learning, the feature extraction can be completed automatically. Yeah. So, and then the number of layers in deep learning, we have more layers than that of in machine learning. So in machine learning, we have three categories: supervised learning, unsupervised learning, and reinforcement learning. Yeah, this is the example of the supervised learning. Yeah, in sorry, unsupervised. Okay, in supervised learning, we give the machine a lot of data, and we give label to that data. So, for example, we give the machine pictures of dogs, many pictures of dog, many pictures of cat, and then we give labels through to those pictures. And then after the training process, we do the testing, and in the testing, machine should know which one is dog, which one is cat. And second category of the machine learning, which is unsupervised learning, we classify objects. We classify objects without any knowledge about the label of the object. So it depends on the similarity distance between objects. Yeah, so that according to the similarity distance, we then classify or grouping the objects according to the similarity. And there are a lot of algorithms in deep learning. They are already there. These algorithms are the modifications of CNN, region-based CNN, fast region-based CNN, fast region-based CNN, and etc. Yeah, I just want to skip this, and then we go to CNN. So CNN is basically the algorithm, an algorithm of deep learning, which take input and then assign importance or learnable weights and bias to various aspects or objects in the image, and to differentiate between one object and other object. But the important innovation of CNN is in CNN, the algorithm is trying to reduce the images into a form which is easier to process, yeah, without losing features which are critical for getting a good prediction. That's the most important thing in CNN. So they try to reduce the dimension or the attributes, number of attributes of the image, so that the process will be much more quicker, much more easier than without reducing any dimension. Yeah. So this is important when you are to design an architecture which is not only good at learning features, but also is scalable to massive data sets, right? So there are two parts of CNN. The first part is called feature extraction. Yeah, in this part, the network will perform a series of convolutions and pooling operations during which the features are detected. We'll talk about this later on. And then the second part is called classification. By using classifier, we then identify what class of objects of these objects. Yeah. This is the architecture of the CNN. So basically, there are two main process, which is called feature learning and classification. In feature learning, from the input image, we do the convolution, and then the activation function, ReLU, and then pooling, and then another convolution for the second layer, and then pooling again, and then if it is finished the feature learning process, then we go to the classification by using classifier to identify what object it is. Yeah. So it is basically is the same. Now, in feature extraction, what will be conducted in the convolution process? We have a kernel, which is called a kernel. Kernel is used to map the image. So for example, in this case, we have 5 times 5 image dimension, and then it is mapped to the kernel, and then multiplied. Each cell is multiplied between the input image and the kernel. So we get the output, which is called convolve feature. Yeah, if you look at the simulation here, the animation here, it is clear that for every part of the image will be multiplied to the kernel, and then we come up with this new size of image, right? If we have a color picture, we have 3 channels, red, green, and blue. The process is basically the same, but we have 3 parts of computation. Yeah, we have 3 channels: the red channel, the green channel, and the blue channel. And for each channel, we flashlight the input image by using kernel, multiply them, and then we come up with the a number, and then we sum up all the numbers to get the output matrix, right? So another process of this feature extraction is called padding. By padding, we means that we flashlight the input image by using the kernel, but it depends on our system, our architecture. The challenge in CNN is how can we configure our architecture which is more appropriate or more accurate to handle our problems. Yeah, there are 2 kinds of padding, which is called valid padding or same padding. Valid padding, we use stride length 2, and then it means that the movement of the kernel should 2 cells to the right, but in same padding, it takes only 1 cell to the right. Yeah, you can look at the simulation here, which is very interesting in using this kind of animation. Say, after that, we have to go to the pooling process. Yeah, there are 2 types of pooling, which is called max pooling and average pooling. In max pooling, we will have to take the maximum value from the portion of the image covered by the kernel. By average pooling, we get the average of all the values. Yeah, people are using max pooling other than average pooling because the computation process is much more lighter in max pooling. We just find the maximum number of the matrix, whereas in average pooling we have to compute the summation, and then we divide it by the number of the cell. Yeah. So similar to the convolutional layer, the pooling layer is responsible for reducing the spatial size of the convolved feature. So this is the max pooling. So for every portion of the cell, every portion of the matrix, we take the maximum numbers that are exist in the matrix. This is more clear that in max pooling, for example, in the left portion of the image, we have numbers 12, 20, 8, and 12. We take number 12. Whereas in average pooling, we have to sum up first 12, 20, 8, and 20, and 12, then divided by 4, which is, then we get 13. So this pooling layer is quite simple to do. Yeah, basically it's try to get the number of the portion of the images, so that the size of the matrix will be reduced. Now, after we finish of the first stage for feature extraction, we go to the second portion of the process, which is called the classification. So the matrix, which is the output of the feature extraction, should be flattened, and then we do the fully connection between this flattened layer with the output nodes. Yeah, if we have, so say for example, we have 5 class of objects, then how can we measure the probability of each image to the output image? Then the highest probability will be the class of the objects, right? So this is the explanation of the fully connection layer. And in CNNs, we have some architectures in CNN. Some of them have been listed below, like LeNet, AlexNet, VGGNet, GoogleNet, ResNet, and ZFNet. So there are a lot of things that can be done by using deep learning. These are the research areas that can be used by researchers or academicians to do the deep learning process. Social network analysis, natural language processing, visual data processing, speech and audio processing, and etc. So the conclusion is the deep learning has already influenced humans' lives significantly, and there are various techniques that have been developed in deep learning. And CNN is one of the famous deep learning methods to deal with the object recognition that can produce high accuracy level. That's why CNN has already attract many attention from researchers, and then they have many modification of CNN and come up with modified CNN, faster CNN, enhanced CNN, improved CNN, and so on. So there are a lot of research areas in deep learning that are open to explore. I think this is the conclusion of my presentations. I hope you can have some inspiration and idea in doing research in deep learning. There are a lot of problems around us that can be solved by using this kind of technology, this kind of techniques, but then we need some more power of computer to process all these things to give solution to our problems. Hopefully my presentation will be useful for you and you get many inspiration from this. Thank you.